should have been more prepared.
No, that's for suckers. Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm managing editor Tom Nardi.
This is episode 155. Today we'll be talking dual integrating spheres, more magnetic switches, PlottyBot, and red hair in your wafers. Today, I don't have any news. Do you have any news?
I don't have any news. They say no news is good news, right? Is that what they say?
That is what they say.
Did I make that
true.
up?
Except not in the news business, I think.
Oh, yeah.
Well, let's see. I was doing some hacking a couple days ago with my son. It's kind of fun. He read a book, actually a book series called Secret Coders, which is about some kids who end up using Logo, basically, to thwart evil and obtain superpowers. So he was all into the Logo programming language and was like, we need to make a Logo turtle bot. And I'm like, uh-oh. So I made a Logo turtle bot, which is awesome. I just some gear motors and some wheels. And we were playing with it yesterday, and the thing will not drive straight. And the gimmick with Logo, right, when it's on your computer screen, is that you can easily drive forward, a finite number of blocks, and then you can turn exactly 90 degrees, and you can repeat these things to draw a square or whatever, right? Getting a real-world physical robot made with two separate DC-geared motors to even drive straight, much less drive straight a controlled distance, is tricky. And I, of course, took the super naive, let's just cobble this together in an afternoon approach to things. So it's all like hot glue and everything. The left motor is so much stronger than the right motor. And I'm like, oh, man. Well, at least we have PWM on there. And so we're sitting there, and he learned so much more. Like, if you learn Logo, you just get to type forward 10, and the thing goes 10 forward. If you try to build a stupid turtle bot yourself, it turns out the thing won't go forward. I mean, it won't go straight, right? And so we're tweaking the PWMs on the left motor and the right motor to make them work. And we finally got it so the thing could drive in a straight line. Victory! Then it stops. And of course, when it stops, one of the motors cruises down differently from the other. And so then the thing turns again.
Oh.
And so he's like, okay, well, we'll backdrive that motor to cancel out its cruising behavior. And I'm like, not bad, kid. And so we do that. And anyway, it was super fun. I'm eventually going to have to put encoders on this thing and do it right with some kind of PID loop or something. But that is not a job for an almost 8-year-old.
Yeah, right.
PID loops is maybe not even a job for me. We'll see if I can rise to the challenge here. But it was just awesome to do this kind of stupid real-world debugging, but it was also kind of all in a way that he could understand, even though it was really hard. It was like, oh, this one needs more, this one needs less, and we were kept driving the thing around in these kind of almost squares with 85-degree angles on the corners, and then 98-degree angles on the corners, and it was entirely frustrating, but an awesome exercise in debugging. And we finally got it to do basically a square, and he was so triumphant that he called his mom down, and she had to come look at it.
The whole time he must have been wondering, it was so easy for the kids in the book, right? They just
right?
They put a couple lines in there, and the turtle bot did its thing. I don't know, Dad might be messing up, but
I feel like I've
got there in the end.
Through my failure, I have taught him an important life lesson. No, right? But your inner perfectionist really wants to take it offline and be like, okay, now you go sit in the corner for a while, and I'm going to implement PID loops on this thing.
Yeah, why don't you go play outside, kid?
But that's not fun. It's fun for me. It's not fun for him. So, restraining yourself from doing that is almost impossible. But victory this week.
I like that, you have a nice heartwarming story. I don't have one of those. I used to try to do electronic kits with my daughter, and it worked fine until she got 11, and then she got a cell phone, and now she doesn't want to build electronic kits with Dad anymore.
Yeah, right.
So all of a sudden things are way more interesting on her phone, though. But there was a time where I got to put things together with her, and it was really nice. Maybe I'll get back there. I'll tell her we're going to build a turtle bot. Maybe she'll be into it.
All right, shall we do What's That Sound?
Yeah.
This is a journey into sound.
What's that sound?
What's that sound?
Oh yeah, extra bonus this week. Tom has not yet heard last week's What's That Sound, so Have a listen. See if you can figure it out while I'll play it softly in the background.
Ooh. Oh, this is freaking me out. I can't get over the impression that I'm hearing human speech garbled in some way. So
Yeah.
my guess is some kind of encrypted radio chatter.
Ding, 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 ding. We have a winner.
Okay,
Yeah,
okay.
it's an old school voice scrambler. In fact, it's the Cry 2001 voice scrambler, which was used for encrypting or at least kind of obfuscating.
Yeah, I probably a better term, right?
Nautical communications. I don't know how this particular one works, but a lot of these work by kind of tuning just a little bit off to the side of the speech. So it modulates your speech with a carrier that's changing all the time and isn't quite on right in the center. And it does this frequency hopping thing. And if both radios frequency hop at the same time, they can demodulate it by having a shifting carrier all the time. And the really fancy ones do it with multiple bands simultaneously. And I don't know if this one's really fancy or not, but you can kind of hear it. And one of our good answers was actually a mistuned single side band signal.
Yeah, right. It sounds like you're right on the edge of being able to understand what these people are saying. And if you
sounds
just
like you've
twiddle the knob a little more.
Got a radio that's tuned wrong, except it's a radio that's tuned wrong all the
Intentionally,
time because it's jumping the center frequency around essentially. So yeah, that's a pretty cool answer.
So what we're listening to, if it wasn't jumping around, I guess this is like just the center, and if we were jumping around, we'd hear it. Okay,
You're on the wrong.
from our perspective, we're right.
Pretty cool old method, and would be like super easy to do these days with DSP. I think this has to be the world's simplest flow graph in GNU Radio or something.
But back then,
I'll throw the link in the show notes. I was looking at this one. The device is actually super well documented. You can actually get the schematics for it if you want to build your own,
cool.
completely out of, like 1980s style ICs and stuff. Screw that. It would be so easy to make a complete replica in GNU Radio. It might actually be fun to try to decode this if you wanted to play around.
I was
with
going to
that
say,
sort of
what
thing.
is this sample? Do we know what it's supposed to be?
No clue.
Oh, that'd be
Two
interesting.
sailors talking to each other. And the problem is it could be in any language, right?
Yeah.
I mean, I think these were used in the North Seas, so it could be like two Finnish dudes talking to each other. So you're going to unscramble it, and then it's still going to be in Finnish.
Now, that's a kind of interesting thought. Is there enough data in this to get the original message, or did we lose that because we didn't?
I think there
is
must.
there stuff
I think
outside
there
of
must
band?
be. Yeah, I think it's probably pretty easy. Like you could probably even make some reasonable assumptions about, what frequency bands belong in human voices, and you could probably even redo it just from that, I guess. I don't know. Actually, this is such an interesting kind of crypto/radio/audio challenge to try to undo it. Would actually be really interesting.
I hope the kid didn't want to work on the TurtleBot because he's out of luck.
Anyway, we got a bunch of good answers. I will have to roll a 6-sided die. We got 5 that I'll consider right. I think my favorite wrong one, I don't know. Probably garbled Animal Crossing conversation.
Oh, wow, that's a deep cut. I like that.
Oh, some droid from Star Wars. That's pretty solid. Good guess.
I like that.
Good
Honorable
guess.
mention. It would work as that. If I was doing like a fan film or something and I wanted to have some droids, I could definitely play that.
It totally is. Here goes my dice roll. And the number is 4. The winner is Stella's dad. Congratulations, Stella's dad. Oh, this was absolutely the best answer. This sounds like the Cry 2001 voice scrambler for use on marine radios, and hands me back the link that I'm going to put for you in the show notes describing it exactly where I got this sample from.
Yeah, I'm pretty sure that's a Fed.
Good job, Stella's dad. You're on to me.
Yeah, right.
I'll send him an email. He'll send me his t-shirt size, and we'll send him a t-shirt. If you're looking for a Hackaday podcast t-shirt, tune in next week and hear what sound comes up next. Straight into the hacks. My first one this week is a video from Zachary Tong. Working model reveals amazing engineering of Webb's mirror actuators. And it puts on display some really cool mechanics of the actuators that move the hexagonal mirrors in the James Webb Telescope. And they all have to be slided into place 6 degrees of freedom, actually 7. They also have another motor on there that can pull them in the middle a little bit to actually make the curvature adjustable. But these are the motors that wiggle them into place. So they've got 6 degrees of freedom arranged in one of those cool like Stewart platforms, which is a bunch of triangles all put together. And so you can go up, down, left, right, and then rotate. It's literally 6 degrees of freedom. And each one of these 6 actuators looks like this. And this is what's shown in the video. They're really cool. They have to be lightweight because they're going to space. They have to be strong and not breakable because they're going to space. They have to be super finely adjustable down to a couple nanometers. And then they have to be coarsely adjustable because the whole thing has to move to get them into rough focus. So there's a whole bunch of crazy kind of conflicting engineering constraints. Zachary Tong prints here a 3D printed model of this using one of those horrible cheap 28 BYJ stepper motors and a bunch of 3D printed plastic. Really cool, actually. The gimmick with these actuators is they've actually got a couple flexures in them. And one is at the top. It's basically like a trapezoid, and you can pull the 2 sides of the trapezoid in, which kind of squeezes it and pushes the top upwards. And then actuating that is yet another flexure that you pull down on, and it compresses a little bit to squeeze the sides of that trapezoid in. And so you've got these 2 weird flexures moving against each other, and that gives it a whole bunch of leverage so that it can do these super minute movements for this like super fine pitch control. Pulling down in the middle has a cam in it, so actually that's another degree of leverage it's got there. But then the part that Zachary thinks is the coolest is the way it goes between kind of this super fine pitch adjustment that I just described to you and a coarse adjusting mode. It's got also a big screw on the bottom that just lifts the whole thing up and down. I think he uses an M8 bolt. They have some kind of funny M22 aerospace pitch bolt or something.
They didn't have it at the Home Depot, right?
And so you turn that one by turning these 2, I guess they would be cams, 2 flat plates that turn against each other, and each of them has a little tooth, but only one tooth, and it's relatively thin. So if you spin the central shaft a lot, eventually these 2 teeth catch on each other, and that spins the coarse adjust. And then if you back off of that, the 2 plates are free to spin with respect to each other, and that only moves the fine adjust. So it's this really super cool mechanism that gives you both a coarse adjust by spinning one screw and this fine adjust by moving the flexures around, all driven with one stepper motor. And that is a super cool trick. And that's probably the reason you want to check out this video.
You need to watch the video.
I did my best, man.
Well, no, you did a great job. You did a great job. I read the article and I was like, I don't know.
Yeah.
I ain't getting it. And you have to watch the video, and specifically you have to watch it. He like does it like 20x speed to see the motion, because it's super, super fine. I thought the coolest thing really about the whole project was that there was enough information out there and like the white papers and stuff from the manufacturer that he was able to, build this thing. I guess it makes sense, right? Like our tax money paid for it. We should at least be able to make a 3D printed model of it. But he was able to, find enough documentation that was accurate enough that he could come up with a working 3D printed model, which is super cool. And then he put it out there. I'm not surprised Dan jumped on this one, because Dan and I had the chance of seeing the James Webb Space Telescope during the 2018 SuperCon, and we actually got to see the back of one of the flight spare reflectors. And unfortunately, this thing wasn't on it at the time. I know Zach and Dan were going back, and he actually, did you get to see it? And he was like, that wasn't mounted to it at the time. There was an actuator in the middle of it that does, I guess, the flex, the in and out, that was on there. And we weren't allowed to take pictures. I should also say that we were sworn to not take pictures. The way they had the mirror, it was kind of not real well lit. And one guy was like, "Can I use the flash on my phone as to light it up?" And the guy was like, "Ugh." Like, you're really not supposed to even have a phone on the premises. So let's just say no. it was really cool to see that and to now know what I was looking at because we saw there was some kind of motor and linkages and stuff, but to actually see how it works is really cool.
What could you use this for yourself? Well, these kind of flexure things, I remember there was a brilliant microscope stage that was 3D printable, and it does all the fine adjustment with flexures. And you can make, that's one of those things where you have a super fine positioning problem like this. So this actually might be really sweet for them because it would give you a coarse adjustment as well as a fine with just the one device. That's actually... I might be a genius. I wonder what else you could use these for. I don't have much micro positioning need myself, but if I did, I would totally be looking into flexures like this.
Regular listeners to the podcast might remember 2 episodes ago I talked about Riskable's Void Switch, which is a magnetic keyboard switch. I was really excited about it. Interested in seeing what kind of different approaches there would be to using this technology and seeing it develop. Since that went out, as often is the case when we write about something on Hackaday, another person has come forward and said, hey, I have kind of my own approach to that concept. And the interesting thing for me is that, like, the highlights are all the same, right? It's 3D printed, uses magnets, uses Hall effect sensors. But in terms of the details, they couldn't be more different. And I think it's really cool how you can start at the same place and arrive at the same place. But the intermediate part is absolutely, they couldn't be any more different. And they have, different strengths and weaknesses. So the one from Famitsu, the interesting thing is it seemed like their goal was to, I'd say, recreate the traditional MX keyboard switch without throwing the rule book out. Whereas I would say the Void Switch says, well, that's cute the way we've been doing things for all these years. I have a different idea entirely. What I mean by that is that the switch is still wired in a matrix like a traditional switch. It doesn't have the analog capability that the Riskables does. It has less parts too, which is frankly an advantage in one respect. And it also does away with the concept of basically you can program the strength of the key, which was one of the things that Riskable was really into. He like that you could say I want exactly this much resistance, and the open SCAD script could figure that kind of thing out. That said, while it's a simpler and maybe a less flexible approach, they're easier to make. They are printed on masked SLA printer, a resin printer, which there's no time penalty for putting multiple objects on the bed. So in a traditional desktop 3D printer, every time you add something to the bed, you're adding print time. When you're doing resin, since it's hitting the whole bed evenly with light, you could put as many, and you should put as much stuff on the bed as you can, because if you're going to go through the trouble of dealing with the resin, you don't want to waste it, right? So you can knock out 20 keys or all the parts, for 20 keys or whatever, easily in one shot without any kind of time penalty, which would make it a lot quicker to actually spin up a full keyboard. Like I said, it's a different approach, but it gets you to the same end game where you don't have springs and you don't have mechanical contacts. And it's, in theory, good for, infinite. The biggest thing that could go bad is the magnets. And if you're waiting for the magnets in your switches to lose the repulsion, you got a while. You got some time. Yeah, you got some time. This is not something you're worried about in the near term at all. And actually, I said in the last episode, Riskable, he loves talking about this stuff. He's very passionate about magnetic keys. So I actually had spoken to him a little bit about this design, and he was real jazzed to see like somebody take a different approach. And I know he had collected up some little notes and was going to get in touch with him, Famitsu, and just kind of awesome. Compare. There were some things that he's like, this might not work the way they're hoping for, and other ones he's like, wow, that's pretty cool. And I like that, instead of it being like this competitive thing where they got, 2 people like, oh, this is the wrong, oh, you're doing it the wrong way, I'm doing it the right way. That we might have some collaboration. And I think that'll be really cool for the future of weird magnetic input devices.
Well, if the 2 people who are working on weird magnet-repelled keyboard switches get together in the same room, like, they're not going to go at each other's throat. They're going to be like, they would have to talk to each other. Like...
Yeah, too weird of interest to not work together.
I have to admit that I like a lot of the advantages of Riskable's design, that you can that it separates the electronics from the switch part. I think that makes manufacturing it a lot easier in my mind. Whereas these have actually a little tiny PCB with the Hall effect sensor and a transistor in there too. I don't know.
No, so that was a little bit weird too, because there's also I should say, there's a language barrier here. This is all Japanese, so,
Right.
So it was a little bit tricky, but we had to go through to the schematics. But you're right. The Hall effect sensor is in each switch, which is different than Riskable's approach. Riskable, there's no physical connection from the switches to the board. So these keys do have pins, and they are plugged in just like a traditional switch. And instead of reading the sensors with a microcontroller, to simplify things, there's just like transistors on each row. And the idea is that, you get enough of a signal from the Hall effects sensor to flip the transistor, and that from that point on, it's basically like a traditional keyboard where you're just reading it in a matrix. If you're out there and you have a third approach, please contact us. We'd love to hear from you.
My next hack is a drawbot, and I have a soft spot for drawbots, and PlottyBot is a drawbot that plots a lot. Is it not?
Ooh, I like that.
Thank you. I've been working on my flow all day. I've been refining that.
You waited all day for that one?
For quite a while. I think I'm going to put a beat underneath it or something. We'll have to see how that goes. PlottyBot is a drawbot, and it's a very nicely built drawbot, and the instructions are absolutely fantastic for this thing. In terms of how it looks, it's a X-style, one pair of rods here, another pair of rods there at 90 degrees to each other, pushes a pen around on the end of it. But it's got nice covers covering everything up. It's got channels in the 3D printed frame through which you can snake the wiring. I think Ben says this is his 6th or 7th revision of this robot. So
I believe it.
This is refined to the nth. And actually, when he's going through his instructions, which are incredibly, like if they were pages printed out, this would be a 100-page manual, I think. You're going to scroll for a while here. And you get to the end of it, and I'm actually doing it right now, so it's going to take me a while until I can read the quote. Good Lord, how long is this thing? Incredible number of pictures. Yeah, when you scroll down to the very bottom, Ben says, I would like to congratulate you for your patience and tenacity for reading this far. I refined this plotter over many years, over many prototypes. I hope I made it free of the blind spots and dark corners I found myself into. And it does. That's exactly it. If you want to build a plotter or a 3D printer or any kind of machine with a couple or more linear axes, you're going to run into all of the problems he ran into in building this thing. And it's a good read, whether you're into plotbots or not. It's going to help you with whatever machine build you have staring you in the face right now. Well, there's a couple great features. One is that he uses a captive nut and bolt to make adjustable feet on the thing. So there's a nut that sits inside a 3D printed housing for it, and then he uses a bolt that goes into that sticks out of the bottom, and he makes a little shoe for it for the feet. So this gives you, screw adjust feet all around, so you can perfectly level the thing and get the height just right. The other feature that really struck me was his cable wrangling, which was to cut some strips out of a plastic folder and tape them all together and then run the cable bundle over that. And this thing is just springy enough that it kind of bows up and it holds the cables in this nice arch. It's a great alternative to a cable chain. This is kind of a cable arch, and it's a cable arch made out of cheap parts you've probably got sitting around. This is the way I'm going to handle my cables next time.
It's funny, that part specifically reminds me, we once saw somebody do a similar thing using sections from a tape measure. They just cut a foot or two away from a tape measure. But this is better because the tape measures, once it kind of gets that kink in it, forget about it, But I think this plastic folder material will be a lot more flexible and quieter too, I'd imagine.
Yeah, totally.
But no, it is a gorgeous machine. I mean, if you told me this was some ridiculously expensive commercial thing, I would believe it. I mean, it looks. One time we saw somebody use shoelaces for for drawing things, right? Not that long ago, use shoelaces and whatever. Even the shoelaces didn't even match. But this is not that. This is everything has these nice little beveled curves. I mean, a lot of thought, a lot of heart went into this. There's a part where He talks about that you could use it with fountain pens.
Yeah.
Because that opens up what kind of inks you could use. And then in that case, there's a specific ink fill routine in the software.
Yeah.
Just in case you have a fountain pen that needs to occasionally like pop off to an inkwell or whatever. Like everything has been considered, and it is really, like I said, if you needed an example, even if you're not trying to do the same thing, if you're just looking at like, how do I make a mechanical thing, and how do I document it, and how do I do the bill of materials, I mean, you would do far worse than following this example.
Yeah, and I'm obsessed with the hardware side, but you mentioned the software, and I didn't even touch on that yet. Like, he's written a whole bunch of software to go with this thing too. It's got a tablet-based handwriting capture app where you can write A in your handwriting uppercase, lowercase, then write B in your handwriting uppercase, lowercase, and it makes a custom font out of your handwriting. And then he demos it by typing, and it writes along with him after he's typed a line of text, right? And it writes in the handwriting that he just uploaded. The bot itself has a Raspberry Pi on it, so it's got a lot more processing on board than you might think it would. And that, on one hand, is kind of cool. I'm kind of one of those people who wants my machines to run G-code, and then I want to talk to them with the Raspberry Pi. But on the other hand, this gives you this like one-stop shop where everything is done on the Pi. And if you're not into this kind of low-level machine-y code stuff, this is much more approachable. In fact, I think it does the motor driving for the stepper motors in Python code even. So like if you're a kind of higher level software type hacker, this is actually going to be tremendously accessible to you. Yeah. And I think that's the kind of place Ben is coming from in making it. But that's not to belittle it at all. It's just kind of a different angle from the Flash Gerbil on an Arduino and, then spit G-code to the thing, which is kind of my background. This is, well, hell, computers are cheap these days. We'll put a damn computer in it and write the code in Python because that's easy and clean. And I appreciate both of these. Don't get me wrong. But that gives it a Wi-Fi. It gives it a lot of processing power on the bot itself. It gives it a lot of room to tweak with the software. And it looks like Ben has done a lot of that already. It's ready for you to make one and start playing with the software yourself too.
Well, this next project is something that has been a personal fascination of mine for a while. And that is, how do you put identifying information into a 3D print? In theory, all the 3D printed stuff you do should be identical, right? But there could be a reason, whether it's, you want to put your serial number in there, or you want to have a marker that when you scan it, it does something. There's many reasons you want a 3D print to have some kind of integrated identifiable mark. And with a traditional printer, that's basically impossible. But this is a really interesting project coming out of MIT that they're calling infrared tags. And the idea is you take a multi-material 3D printer right off the shelf, nothing crazy, and you load it with two different kind of filaments. You load it with your regular run-of-the-mill off-the-shelf PLA, whatever, and then another filament that is not entirely, but mostly translucent to infrared. You print your design to the naked eye, it looks totally normal. But then when you use an infrared camera, it can see through that outer layer and see inside. And in this case, they're embedding 2D QR codes that could be scanned by an app and do whatever. But it could just as easily be plain text or pictures or whatever you want. As long as it's using that opposing filament that you can't see through in infrared. They show a lot of interesting applications of this. They show a 3D printed router enclosure that you can scan to get the Wi-Fi credentials. They show obviously being able to put like a maker's mark into the printed object if you want to sell these things. But, let anybody know who designed it. You could embed your own kind of invisible tag in there. This is not a new problem, right? Anytime you have machines that can pump out duplicates, somebody wants to know, well, how do we figure out who made it and where did it come from and, who's responsible for it? So there's been different attempts in the past to, for lack of a better word, fingerprint 3D printers and try to say, okay, well, it's sort of the way you do ballistics, right? You say, okay, well, the nozzle has a certain kind of groove to it, and the stepper motors have a fault where every couple of rotations they move a little bit. And you try to collect all these little minute details about a printer and come up with an identification and try to work that backwards. And so far, that hasn't worked in the real world. There's been many attempts at it, but it's too many variables.
Hard
But
problem.
with something like this, yeah, it's a very hard problem. But with something like this, where you imagine a future where the printers could be embedding their own ID into objects. And I am leery of any kind of DRM like that working its way into 3D printing. But, if you look at something that's being printed on like the industrial scale, where it's important to know the background of a printed part or something, I could see this being something that in the future becomes more common.
I really like the idea in principle because, I mean, their applications are all kind of consumer, household, non-nefarious applications. And they're all like, we can hide the password on the bottom side of the router using this QR code. And I look at that and I'm like, it's on the bottom of the thing. You could just print it out on a piece of paper and stick it there. There's no reason to do it. But then what this does that you can't see it with your naked eye, but the camera can see it, is it really does make that tag or fiducial mark or whatever kind of magical. And I think that's the important part of this interaction for the end user / muggle, is that my augmented reality device knows something about it that I don't know. And I think that is actually really cute. I'm not so sure it's groundbreaking. Like, I went through the video and everything they're doing with it, you could do with one that's printed in visible light, basically. Like, how often do you need to hide cryptic signs in 3D printed objects?
And that's why I looked at it as more of a tool for identification and stenography almost, where, I could imagine a future where maybe not your $300 Ender, but a much more high-end printer could just be, dropping little IR tags into a printed part automatically, so that, if you're on the assembly line or something, they need to know what printer, where did this come out, when was it printed, what time. There could be these little integrated tags.
I guess the printed ones look ugly. I guess, I was thinking, you could do this for like property tagging or something like that. And then I'm like, but you could just put stickers on them. And then I'm like, but then you have stickers all over your stuff.
Yeah, and then that's a second machine. That looks the sticker
dumb.
On too, right? If you could do it while you're making it, And it's also under the surface too. If you did a printed barcode or something on the surface, it could wear off, it could get covered. I mean, this is protected as long as the object is intact, you know what I mean? Unless it's cracked in half or something. So even if you got surface wearing and stuff, you could still look through there. So I think there is, some potential there. We should say, though, that like in the video, they show people scanning it with their phone, and that's cute. But what you might not realize, unless you watch the whole video, is like on the back of the phone is a big unit, that's using a Pi and infrared camera, because the regular smartphone camera doesn't have that kind of infrared. The difference between the filaments is not great enough for like a regular, like you said, muggle camera. They have to use an actual IR camera. So this isn't, despite what you might, frankly, what they want you to think looking at the thumbnail, you're not just gonna pull out your little burner phone and scan this thing and get it. There is still a special piece of hardware, but that kind of speaks to like what you were saying. Their applications are very consumery, but that's a huge hurdle. If you can't actually do this with a real phone and you have to have a dedicated scanner, but that doesn't necessarily make it a problem for like an industrial process or anything like that, where it's not a big deal. So I think that this is one of them cases where they show you a teacup with a fun little QR code that's easy for investors to understand.
Right.
And then you go and then you sell it to the people who really want it, which will probably be the military or something.
Actually, this reminded me of a write-up that Joshua Vasquez did of a technique that he uses with his Jubilee 3D printer, which is that he has a custom OpenSCAD plugin that puts like a model number and a revision number into all of his parts. And that's integrated with his workflow. So like the GitHub checkout hash for the part that you printed is printed into the part itself. And this helps him with debugging when a whole bunch of people have printed this printer, which is in a rapid state of development. And it's like, oh, which version of the part do you have for this? Nobody knows which version of the part they have for that, except with his system, they can just go read the number off of it. And that corresponds directly to a GitHub checkout that would help them build that part again. I think that's immensely clever, and that's something I've been meaning to put into my builds when I do something that formal again. I'll find the article and throw a link in the show notes.
Yeah, Prusa actually does that with some of the printed parts on at least the Mark III.
Oh, really?
They'll put revision number on, not on everything. I mean, some stuff doesn't
Yeah.
change that often, but like if you ever take apart your extruder, there are revision numbers built right into the printed parts, which I thought were pretty cool. They're not using OpenSCAD anymore, but they originally were. So it's probably very similar to what he was talking about.
Yeah.
Just building it into the workflow.
All right, Tom was talking about two different kinds of maglev switches. I've got Ulbricht spheres implemented two ways, so this is a twofer this week. I've got one less using a cannonball mold to make a dandy integrating sphere for laser measurements, and I've got the torque test channel. Is your flashlight a lumen liar? Build a DIY integrating sphere. And these are two takes on the same thing, which is to make a sphere, a ball, that is painted with as reflective as possible, but still diffusing paint on the inside, so that if you shoot light in one side, it bounces all around, bounces, averages out. And then if you put another hole in at 90 degrees to that, the light that comes out that hole is been completely mixed up and perfectly diffused. This is useful for a couple different things, and these two different posts coming out in the same week highlight this. Les is using it to calibrate his spectrometer, and to get nice, reliable wavelengths to do this calibration, he wants to use lasers. But lasers put out a point light source, and if you try to put those into a light level meter, it's either hitting the sensor or it's not, and it's wiggly, and it can be hitting it in a hard spot, and it can be only illuminating part of it. It's just a bad deal. So he takes a cannonball mold, and these are brass or bronze. Anyway, they're metal. It's a two-part mold that has a sphere cavity in the middle, and he paints it with a mix of barium sulfate, which is the super white in it, and PVA glue, which is like Elmer's glue. Les's application here, anyway, is taking a laser and kind of diffusing it out so that he can then read on it. Torque Test's channel's application, on the other hand, is to get a nice, even illumination field for measuring how bright flashlights are. So they're taking a bunch of LED flashlights, comparing them against each other, and they've got a lux meter that has it's maybe a square centimeter sensor. And so the question is, how do you get that into the right place in the beam to measure exactly how bright it is? The answer is you can't do that. What you need is one of these super reflecty spheres. They paint the inside of these styrofoam spheres with, hold on to your hats, barium sulfate and white paint. So barium sulfate seems to be the absolute common denominator here, and it's the whitest
Right.
thing. We had a hack about a year ago talking about applications of super white paints, and this is the whitest paint may help fight climate change. The idea is you put this on roofs and it reflects all the heat off of your house, which is actually a great idea. But you won't be surprised to hear that the white that they're using in this new whitest paint is also barium sulfate. And it sounds really fancy, but it turns out it's available for something like $5 a kilogram if you look in the right places. So it's actually dirt cheap. It's the thing if you need to make a white paint that's like ultra reflective and doesn't change the color, particularly of what is being reflected off of it. This made me think, even if you don't need to cool your house with ultra white paint or make your own DIY light test apparatus, you could probably make your fancy glowy LED widgets better and smaller by just fetching yourself some of this barium sulfate and mix it into your paint.
By the way, where do you get a cannonball mold? That was the weirdest thing to me. Like, I'll just go to the store and grab my cannonball mold. I guess of the two of them, I like the Torque Chest channel one because at least they were, verifying their LED lights, and I guess they're mechanics on that channel. So this was like not their normal. This is not their normal thing. They usually they need bright lights because they're under cars, and they're so they were like, we want to make sure we're getting what our money's worth. So I thought that was kind of cool. One guy's measuring tunable lasers that we can only dream of, and they're just trying to figure out, did the Harbor Freight LED headlight did they screw us over compared to the Amazon versions. So I picked this last one because it hits particularly close to home. A story about how Cody of Cody's Lab is trying to grow algae in great enough concentration that he can eat it and live off of it. And I am only mildly embarrassed to admit that I thought the same thing a few years ago and had fallen down a remarkably similar rabbit hole where I thought like this was the future. Why aren't we all eating homegrown algae? And it was kind of cool to look at this project, and right off the bat I should say like his scale is way bigger than I ever attempted, but there are a lot of the same kind of milestones that I recognized in watching this video. And I was like, fantastic. Oh yeah, I tried this. Oh yeah, I tried that. Oh yeah, it doesn't taste very good, because the end result for his project and mine was about a tablespoon of green goop that was edible, at least on paper, and tastes a lot like grass. Not that I've eaten freshly cut grass, but
that's not
if
bad.
Could have been worse. If I had to imagine. Oh yeah, it wasn't. It smelled of shrimp and tasted like grass. So I suppose in the grand scheme of things, it could be worse. But if you yourself decide to try to grow algae at home, a lot of the attempts just use like a plastic tote, which is what I had actually. I had like a plastic clear tote with bubblers and stuff like that. But what Cody is doing is building something that looks a lot more like a solar panel, and not a photovoltaic solar panel, but the kind of warms water where you have tubes going through the center and you're pumping the liquid through it. It seems easy, but there are a lot of little cool details in the video. And I should say it's like a 20-minute video, so he takes his time with it, but you have to watch it to see all the little bits. Like, the tubes are not just like off-the-shelf plastic tubes. He gets 1-liter drink bottles and he cuts the ends off of them and he puts them together with silicone and stuff. So that's cool. I think he takes like 100 bottles out of the recycling and basically gets free tubing that way. And then he puts it into a little frame that he builds. And there's a manifold on the bottom where the pumped in liquid fills it. And, they all connect to it with little T-pieces, but he says they can't just be all the same because you'd have the first tube would get all the pressure, right? Like you'd have all the pressure go in the first tube, that would fill up, and then you have, the concentration would be weird, and he's trying to get the algae to move evenly through this whole array. So by hand, each T has like a little plastic wall in it that he has to drill a hole in, and he just kind of goes through his drill bit set. So each one is slightly larger than its predecessor, nice. So, the small one goes closest to the inlet and they get progressively larger. And he shows in the video, it actually works really well. So like the pressure comes in and they all pretty much fill at the same rate. If it were me, I might turn to like, that's a perfect application for like the 3D printer, right? Like have it, print some ones, and actually you could, especially did like OpenSCAD or something, you could have like a little algorithm that makes each one progressively smaller. But in a pinch, doing it by hand with your drill will work. And then they fill up from the bottom. It's an angled panel, and then they go to the top. They kind of go through another T that he's got hooked up to an air intake, so it bubbles it. It's a very clever setup. So having done this, I'll tell you my biggest problem. And I think ultimately he was using a different species of algae. I'm going to say it must be much harder than whatever I was using, because my problem was once the water temperature dropped below like tropical highs, the stuff died immediately, and I could never keep it. You would need to have active heating, in addition to the aerating and the pumping it, and it just becomes a point where it's like, well, I'm putting so much energy into this thing just to eat some green goop. Maybe I'll just get some lunch meat or something. Like, it wasn't worth it. I know the stuff I was using, I think the water had to be 80 Fahrenheit, which is, I don't know, what's that, 26, 27 or something Celsius, something like that. Like, it had to be hot. Like, it was not, not like boiling water, but it had to be water. It would never stay this temperature, on its own in your house, right? If you left it out overnight, it would get too cold and it would die. He actually, at the end of each day, it pumps it into just a drink cooler that he has heaters in, and because of it's so insulated, he doesn't need to pump so much energy into it, to keep it warm. Whereas if you're trying to keep the whole panel warm all night, it would be ridiculous. So it kind of hibernates. They all go into this little safe space where he can keep them warm, and then in the morning when the sun comes up, it pumps it back into it. So it's a really cool setup. If you're wondering, does it make enough algae for him to live off of? The answer is no. Not by the
Not
longest
even
of long
close.
shots. I think he says this is 2% of his caloric needs for the day.
Yeah.
But at the end of the video, he says, okay, so if I get 2% out of this thing, if I make 50 of them, I'll be there. And he says that's what he's going for. I'll be interested to see. He says he's learned from this design. There's things that he wants to tweak before he goes into full scale production. But he says he's looking to build 50 of these and pulling the algae off of them every day. And I don't know if he's eat it pure or I hope you mix in something. I don't know. Maybe I can find a picture of my own little half-ass attempt. I'll put it in the show notes.
Oh, dude, you definitely should. My first quick hack this week is a riddle. Greg Davo has posted stuff up on Twitter. He's got the mystery effect causing LEDs to glow during reflow. He's got an electrolytic capacitor and an LED, and when he heats it up to 100 degrees C, the LED starts to glow. And the question is why? I don't know. He doesn't know, but he's done some experiments. Go read up on it. Next up, Joe Vingbermühle has made a computer, a PDP-8-like discrete transistor computer called the Q2 out of 1,094 2N7002 MOSFETs. This is a computer built straight up from the MOSFETs. But not only does he have this super simple computer working, he's written a compiler, a simulator for it, the whole enchilada. It even plays Snake. This is a superb transistor to computer all-in-one project. You have to check this out if you're into DIY computing. And last up is IMSci Guys, How to Spot a Fake Op Amp. This is partly about spotting fake op amps, but partly a lecture about what offset voltage is in op amps and how to tell. He orders a set of outrageously, unbelievably cheap OP07 low offset voltage op amps. Surprisingly to nobody, they're probably 741s in disguise. They have that characteristic 1.5 millivolt offset voltage. So you don't get anything for nothing, but what you do get is a great tutorial on op amps and offset voltage in particular. So go check this one out if you're playing around with analog electronics.
My first quick hack of the week is swapped dash module gives Ford Maverick an upgrade. This comes our way from the Maverick Truck Club forums. Ford Maverick, if you don't know, is Ford's new attempt at getting the youngins excited about driving a pickup truck. It's very cheap. It has a lot of high-tech stuff. But it does, from the factory, come with old-school analog gauges, and not all the owners are thrilled with that. What they've been trying to do is take the dash module from a high-end Ford that's built on the same platform and install it, and as luck would have it, it works almost out of the box. There's some little tweaks that need to be done, possibly in the software, possibly in the wiring, stuff like the fuel sender is 50% off, and the cruise control is kind of hinky. But all the gauges work. You can drive the car. And the interesting thing here in the comments were there are equal, if not more, people who would like to take their digital dash out and replace it with the cheapy analog one than there are the inverse. So whether you have a high-end Ford and want to put old gauges back in it, or if you have the cheap Ford and you want to take the digital from it, it seems like it'll work in either direction. Next up is hard drive centrifuge puts COVID-19 testing lab in a backpack. As the title says, this is a way of making a small mobile centrifuge for doing COVID-19 tests, but I think that kind of buries the lead a little bit because the centrifuge itself is built from e-waste. It's very small. You can carry it around with you. There's plenty of medical applications for that beyond just COVID-19 testing. So I think that the design for the centrifuge itself has a lot of life in it, especially for medicine on the front lines and that sort of thing. And last up is 3D printed radiation shields get put to the test. No, this is not a way to survive the next World War. Radiation shields, in this sense, are also known as Stevenson screens, and they are used to protect your little temperature and humidity sensors from the elements when they're mounted outside. This white paper talks about making them out of 3D printed plastics, and it'll probably surprise no one who's printed in PLA to find that the cheapy plastic does not do very well in the elements for too long. But the good news is that there are other filaments that work. ASA is one of them. And also, they found that if you simply covered the PLA with a UV blocking coating, it works just as well. So there is hope for cheap 3D printed Stevenson screens as long as you either pick the right material or treat the cheap stuff properly.
Hold on to your hats. Here come our can't miss articles. These are long form articles written by our fantastic Hackaday writers. And this week I'd like to pick Dave Roundtree's Hair Today, Gone Tomorrow. 4 men go to fix a wafer prober. And this is a lovely story from Dave's past as an integrated circuit design and testability engineer. This one is one of those cases that you get called into if you're on the fix-it team. And spoiler alert, the answer ends up being an operator's mustache hair is stuck in the probe. But that's not the point of the story. If you think I spoiled it for you, you haven't read this post. Because what the post is really about is all of the nitty-gritty in design and testing ICs and IC test equipment. And Dave's inside knowledge and his past working in the industry shines through here. I'll give you a little Hackaday behind the scenes. Dave wrote this article to be twice as long as it was, and I had to cut it down ruthlessly, and even so, I couldn't get it to fit, kind of our usual long article length. Like, he's got so much more expertise in this. I have saved all of the cuttings and handed them back to him and said, look, Dave, you absolutely have to write us up another article about IC Fab, and he's got tons of industry experience, so I think that won't be very hard to twist his arm on this one. If you're making ICs, you want to test all of the different dies on the wafer, and there's a whole bunch of specialized testing equipment to do this. In the end, it all comes down to kind of a custom-made frame that's got a bunch of little microprobes on it, and these come down on special test lands on the die, make contact with them, test it out, and just see if the chip is doing what it ought to do. That's what went wrong here, and that's what they were debugging. The answer was a piece of this guy's beard was stuck in between the little ultrafine needles in the prober. The story also ends with the classic, we've looked at everything. We can't figure out what's wrong. We've checked this, we've checked that, we've checked this, we've checked that. There's no way it could, we can't figure out what's going on. And Dave comes in from the outside, as the guy from outside always does, and says, wait a minute, is it possible there could be something in the probe head? And of course, these probe heads have hundreds of microfine wires on them. You don't want to handle them unless you really, really need to. So they're all totally reluctant to do this. So that's where they didn't check. And of course, that's where the problem is, right?
That is a good lesson, right? The problem is likely where you don't want to look at all.
Well, I mean, you look all the places that it's easiest to look first, right? This is the one thing I've learned from talking to good car mechanics as they work on my car. I'm like, is that the most likely thing? And he's like, no, but it's the cheapest thing to fix if that's what it is.
So cross your fingers and hope we hit it on the first one.
And then it's like, oh, that wasn't it. I'm going to need another 4 hours. And then, then your life is lousy. So there is some benefit to start with the obvious, start with the quick to fix. But then once you've ruled all that stuff out, it's just getting up the courage to look at the hard part that you don't want to look at and find the probe operator's red beard hair in the probe.
And I love the way he describes it too, like the curly ginger hair. And please, everyone who's listening, go and look at the original art for this post.
Oh, dude,
Because
yeah.
it is curly, it is ginger, and the look of surprise on this gentleman's face when he realizes he is the cause of all this problems. I was almost, in reading it, I was almost confused because, he starts with the intro saying, I'm going to tell you a story, and then goes into like the deepest of deep dives about the equipment that tests these machines. And I was like, where's my story? Where's my story? Like, I'm looking for the story. And you put it perfectly. Like, it's not a spoiler to say what the end result is, because that is literally one sentence at the end of the post is like, and it was a hair. Like, all the meat of this is really his firsthand experience with these machines and talking about how they work and like, all that kind of stuff. So on one hand, if you were looking for a yarn to be spun about it, there's only a little bit of that. But if you ever want to know how these chips are tested and that kind of stuff, I mean, this is an incredible resource. And like just a look at the different stages and everything. I definitely would be down for a continuing series of his stories. Tales from the Chip Fab. So my can't miss pick of the week is Crimping Tools and the Cost of Being Cheap by Maya Posh. In our notes for the podcast, I call this the continuing saga of hackers trying to make proper crimps. Because that is really what this is. Like, we have run many stories about crimps and crimpers. We've had people come speak at the SuperCon about like the art of crimping. It's one of those things that seems really easy, right? You squeeze some pieces of metal on some wire and you go about your business. But it is not. There's a lot of physics involved. And if you do it wrong, Maya talks right in the beginning about a cautionary tale about the rash of fires they were having because, this company, they were selling AC units and they got their power cords from a different company and they were using bootleg crimpers. They were using the cheapy stuff and they were crimping the wires and it wasn't doing it tight enough. That introduced resistance that brought the temperature up and caught fire. So like this is a real thing, not necessarily for the kind of stuff we do. I would hope I would hope that most of the stuff we build isn't in like a
20 milliamps at 3 volts. You don't have to worry about it, but
there's no reason to not do it right, and that's kind of what the article is. Like, even though the stakes are lower for the kind of stuff we do, you're only going to benefit yourself if you know how to do it and you have the right equipment. And I got to say, I felt kind of targeted in her first paragraph because, as you might get the impression that all one has to do to join the world of crimp awesome is to order a $20 tool and some assorted, and then in quotes, DuPont connectors. And I can just turn my head slightly to the left and see that $20 kit that she's talking about, and it is garbage. I got it on Amazon and it said they're DuPont connectors. They aren't. And the crimp thing, it looks like a pair of Fisker's kids scissors that they just put some little curly thing on it. It's garbage. And I know that. And every time I use it, I hate it because I can't get the thing to work right. And I don't know if it's because I'm not doing it right or the equipment's not right. It's probably a mixture of both. But at least the article like this can make me feel a little bit better about myself that, we're all dealing with like the scourge of bootleg parts. And it's not just the tool. It's a big part of it is the tool. But also, as Maya shows with some like pictures side by side, it is the connectors themselves. When you're getting these 100 connectors for a couple bucks from the usual suspects, they're not the real deal. And if you look at one next to what it's supposed to look like, you're like, oh, like I see where the problem may come in. Like it's like a child's version of what the real one is.
Yeah.
So you set yourself up from failure right off the bat. You have the wrong connectors. You try to put it on with some tool that isn't really crimping it to the proper, what's the word? Shape. Shape was not, for anyone listening in the audience, shape was not the word I couldn't think of. There was a much more technical term that escaped me. But you get the idea. Like, they're not doing it to the right perfect circle, but a lot of these things do like a B or a D kind of shape, which just isn't right. It's not the way it's supposed to be done, and then it doesn't squeeze the wires, and you have a bad time. I think this is something that probably a lot of our people have run into. And at the very least, it's validation that it's not just you. Like, it's not something you're doing wrong. It's because we were all kind of conned into buying the cheap crap and we're struggling to make it work. Now, what's the alternative? I hope not the $500 crimpers.
Yeah.
But it seems like maybe Maya talks about trying to grab them secondhand. on eBay, you know, but it's even still, I mean, it's a tall order for the average hacker, right? We don't necessarily have the kind of budget for that, or even the space to store all these kind of tools, or, you know, you're trying to make
crimp
things work.
things once a month, not 10 times a day, you know?
Yeah, I mean, yeah, especially something that you're not going to use every day. It's a really hard ask to say, hey, you know, spend what you could get a oscilloscope for.
Yeah,
you know?
right.
Like, you're right. I mean, there's way more useful things you could get, honestly. So, you know, the takeaway is, I don't know, maybe crimps are not the domain of the home hacker. Maybe we're better off just soldering things. But then we haven't even talked about the comments. The comments were heated, to say the least. Because some people swear by, you know, hey, all you got to do is say the proper incantation and spin backwards 3 times, and the cheap ones work perfect, you know?
You just need to squeeze really hard. How hard is really hard? Well, you know, really hard. Hard enough,
right.
Not too hard. But I'm with you. I am in that state where I have, you know, the ultra cheapies at the moment. I think I have a $10 set of crimpers that, like,
I might have sprung for the $20 one.
I think you're the next level ahead. Yeah, but there may be a sweet spot here. And Matt Millman, whose blog Maya is drawing on for a lot of this stuff, actually goes through the kind of the cheapies and sees if any of them are worth it. And there are some kind of $30, $40 crimpers that he'll review and recommend. So there may be some hope for people who are willing to splash out a little bit for crimpers to get something that, even though it's not quite right, you know, even though it makes kind of crappy squished ovally crimps instead of nice circular ones, still totally works. And that might be what I'm gonna pull up for next. We'll see. Or maybe I just won't, because the other alternative to crimping, right, is just soldering. And I'm really good at heating up metal and slopping it around.
I like that. Yeah.
And like that doesn't bother me. I do appreciate the ability to separate connectors when you have you know, when you have something that's built with 5 different modules and you need to pop one out to work on it. Then you really appreciate that everything's connectorized. So I understand that too. But frankly, in my builds, like, everything's glued down with hot glue anyway. When I need to pull it up and work on it, I gotta unglue it. You know, you gotta hit it with the heat gun and pry it off. And at that point, I might as well also desolder it or just snip the wire and solder it back together later. I don't know. There has to be a better solution, but I certainly don't have it. And maybe I will pony up for one of these more expensive crimpers, but $40 buys a lot of solder too. Argue in the comments, crimpers, anti-crimpers.
Yeah, continue to argue in the comments.
It's fantastic reading, and it's funny that this is one of those things that like brings it out, but then I'm totally with everyone here. You know, when I do a bootlace ferrule, does it stay on if I pull really hard? If I pull kind of hard? Is that good enough? So
I'm not even confident enough in the crimps to test them. Like, if I pull it, it might come out. I'll just be like, well, the weight of the connector didn't pull it off, so off you go.
Good enough. And that wraps it up for this week's Hackaday podcast. Write to us, editor@hackaday.com. Check out the show notes and links, hackaday.com/podcast. Send us tips if you got them, tips@hackaday.com. And until next week,
keep on hacking.
We have to share the 100 milliseconds.
What is that noise? And I thought it was having some kind of an aneurysm. Remember that time I said we could do this live? Yeah. I was a fool.
So young, so naive.
Regular wrestlers. How about we speak in English?
Regular wrestlers.
Regular wrestlers. If you're a regular wrestler.
Router. Don't
let me change you. You do whatever you want to do.